Alright guys, another essential skill you will need starting at grade 11 is to graph rational functions. Rational functions are basically functions in the form of fractions. So the tricky thing about rational functions is that you have to deal with restrictions. In other words, the denominator cannot equal to 0. And how you exactly treat the restrictions depends on what kind of restriction it is. If it's a cancelable restriction, then it is a hull. If it is not cancelable, then it is a vertical asymptote. Take, for example, x minus 4 over x times x minus 4. Say this is a function. We see that x minus 4, this restriction can be canceled. So that means x equals to 4 is a hull. And if you look at x, 1 over x, we know that if you have 1 over x, then x cannot equal to 0. So that means x equals to 0 is my vertical asymptote. And of course, you will also have horizontal asymptotes, but let's demonstrate that through this example. So I have a function up there. It looks really complicated, so I'm going to try to simplify it before I try to graph it. Right off the bat, I see that this division sign is really troublesome, so I'm going to try to get rid of it. So we know that dividing by something is multiplying by its reciprocal. So I'm going to first try to flip the second fraction. X squared plus x over 2x minus 3 times, we're going to use the dot as the multiplication sign, because if we use the x, the thing that crosses, then it's going to look too much like an x. So we're going to flip the second fraction. It becomes x minus 4 over x squared minus 3x minus 4. Then I'm going to try to simplify by factoring, see if I can cancel anything out. So for the first fraction, right off the bat on the top, I can take out an x, and I'm left with x plus 1. And on the bottom, it's already in the most simplified form, so there's nothing I can do. Then for the second fraction on the top, there's nothing I can do, x minus 4. And for the bottom, if you use the factoring technique for quadratic functions, you'll get x minus 4, x plus 1. So at this stage, we can see that x equals to 4 is a cancelable restriction. So is x equals to negative 1. That means we have two hulls at x equals to 4 and x equals to negative 1. So the simplified function becomes x over 2x minus 3. Okay, remember my denominator can never equal to 0, right? So that means 2x minus 3 shall never equal to 0. That means x cannot equal to 3 over 2. And that is my vertical asymptote. So x equals to 3 over 2 is my vertical asymptote. Okay, what about horizontal asymptote? Okay, that's actually a little bit more complicated. It requires an understanding of limits, because horizontal asymptotes is basically saying as x gets infinitely large, what does the function approach, right? So we're actually solving a limit of this function, which simplifies down to x over 2x minus 3. And I want to see the limit as x approaches positive infinity. So actually, limit is a more advanced topic. You probably you need to understand that before you can solve calculus. So you're usually by the beginning of grade 11, you haven't touched this topic yet. But let's try to make it simple. So just on your calculator, plug in a really big positive number for x, such as 1,000,000, and see what this function approaches. So you'll see that this function is approximately 1 over 2 as x gets super big. It's about 0.5. And similarly, if you do the limit of this function to x over 2x minus 3 as x approaches negative infinity, well, it's actually approximately negative infinity over negative 2 infinity, so which is still 1 over 2. So that means my horizontal asymptote is 1 over 2. To be more exact, y is equal to 1 over 2. Okay, now we actually have enough to graph this function. We know that in general, rational functions of first degrees, right? They look something like this. And in between are your asymptotes. your horizontal asymptote and your vertical asymptote. So something like that. So let's first draw a set of xy axes. And the first thing we're going to put on the graph, are the asymptotes. So we have a vertical asymptote at x equals to 3 over 2, so that's about 1.5. Let's put that here. 3 over 2 is my vertical asymptote. I also have a horizontal asymptote at y is equal to 1/2, so that's about right here. You want to label that on your graph. Then we know that because it's a first degree and it's a positive rational function, it looks something like this. And my question is, okay, what are my intercepts? Because clearly if you look at this left part, it crosses the x-axis and it crosses the y-axis. So it's probably beneficial if we solve for the x or y intercept. If you plug in x equals to 0, you'll see that fx is actually equal to 0. So that means this graph actually crosses the origin. It is both the x-intercept and the y-intercept. So then I know with certainty that this graph must cross the origin. And we can put a check mark beside the horizontal asymptote, vertical asymptote, then I have to deal with my holes. I have one hole at x is equal to -1. So at this point, right? And I have another hole at x equals to 4. So it's about right here. And now I have completed my rational functions graph.